Good day. How are you doing today? So in this lesson, I'm going to show you how to differentiate the exponential function. So if you are given, if y is equal to e to the power of the function of x, so the function of x on this power can be like a polynomial, either x squared plus 3x or x cubed plus whatever values. The way to differentiate this function is very simple. You just say the derivative, which is dy dx, in this case, will be equal to what you do. You differentiate this part, the f of x part. You differentiate this f of x part and find the derivative of that part, and then you bring it down. So the first derivative of x, so that is the first derivative of this part here. So you differentiate that algebra, we call it algebraic part. So you differentiate that algebraic part, then you multiply with the original function. Then that will be e times f of x. So in simple terms, the dy dx will just be equal to the first derivative of x. Remember, the derivative of that function, multiplied by e to the power of f times x. In simple terms, you just rewrite the whole thing here. And that is how you determine the first derivative of an exponential function. Okay, let's get into some examples. So in this example, we are asked to differentiate e to the power of 2x. And remember what we said, the derivative of exponential function. So this is like y is equal to e to the power of 2x. Therefore, the derivative will be, we have to derive, this is the f of x part, we derive that, and if we derive that, that will be equal to, so the dy dx will be equal to, that will be a 2. So the derivative of 2x is a 2, so that will be a 2 times e to the power of 2x. So in simple terms, dy dx is just equal to 2e 2x. And that's how you differentiate that example. Then moving on to the other example. In this question, we are asked to differentiate e to the power of 6x plus 10. So the same applies. We still have got our f of x here. So we derive that f of x. Therefore, the derivative dy dx will be equal to the derivative of this part is equal to 6. So that will be 6 times, then we just rewrite the whole thing. That will be e to the power of 6x plus a 10. Therefore, the derivative dy dx is just equal to 6e to the power of 6x plus a 10. And that's how we differentiate that. Then moving on to the example number 3. So in this case, you have got e to the power of x at the denominator. So you don't want to derive when it's like that. So it's better to rewrite this thing applying the laws of indices, and that will be e to the power of negative 4x, like that. Then to derive that, remember, you find the derivative of this part, and that will be equal to, so dy dx will be equal to the derivative of negative 4x will be a negative 4 multiplied by e to the power negative 4x. So you just derive that, you write it down, then you just rewrite the whole function as it is here. And that is how you differentiate it. So then the dy dx in this case will be equal to negative 4 e to the power negative 4x. And that's how you differentiate this function. Then moving on to the fourth example. This part has got two terms. So you've got that term and that term. So you just differentiate them separately using the same principles. In this case, your dy dx will be equal to, you find the derivative of that part, and that will be 2x plus 1. So you write your 2x plus 1, and in this time you have to write it in a bracket because you have to multiply by 8e to the power of x squared plus an x. Then here you differentiate again the algebraic part, and that gives you just a negative 3 times e to the power 4 minus 3x. And then you just simplify this whole thing. That you can just leave this one like that, that 2x plus 1, 8e to the power of x squared plus x. Then here it becomes a minus 3e to the power of 4 minus 3x. And that's how you differentiate this function. Then moving on to the last example. So in this example, we are asked to find the coordinates of the minimum point on the curve with the equation y is equal to ex minus x. So in the previous lesson, I showed you how to determine the stationary points. So to determine the stationary points, remember at the stationary points, dy dx is equal to 0. So our dy dx of this function will actually be equal to, so we derive that, the derivative of that, it's of x here, it's a 1. So then it's just e to the power of x, because that's 1 times e to the power of x, which is just e to the power of x, minus a 1. Then you remember at the maximum or minimum point, the dy dx is equal to 0. So we equate this equals 0 is equal to e to the power of x minus 1. Then we solve. So therefore ex is equal to 1. And remember, any number that we need to raise to the power, any number that is raised to power 0, so eb to power 0 is equal to 1. So then your x should be equal to 0. That's how we get the x coordinate. But then we want to find the y coordinate. So to determine the y coordinate, we take that x, we substitute into the original equation. And that will be y is equal to e to the power 0 minus 0. And remember, any number raised to power 0, it's a 1. So then the coordinates of the turning point here, it's actually a 0 and 1. And that's how you differentiate the exponential functions. Thank you.